Okay, hello everybody. We are on stream. Hello everybody. So we're going to be doing the marathon stream today. We are going to be doing 2022, 2022, 2012, 2013, 2015, and 2019. So you can very clearly see the kind of evolution of the MAT here from just being the Oxford test to then being the Imperial test and then also being the Warwick test. So that's quite cool. We're going to be doing papers spanning a whole century here. Definitely, definitely. I will say, let's see. This is a paper. I haven't looked at any of these papers yet. In fact, we shouldn't do that. But today is going to be a little bit different to the previous attempts because I went ahead and I looked up how long is the first section of the MAT supposed to take. So now you'll note, right, that you'll note, if you can read, that this is a 2.5 hour test. And let's see. And the first part, right, A, is 10 questions, and each question is worth 4 marks, right? It should say, yeah, each part is worth 4 marks. And so that means 2 hours, right? 2.5 hours, that's this many minutes, times 40 marks divided by 100 marks, which means actually you should have like an hour to do this, to do the first part. Now, of course, are we going to actually take an hour? No, we aren't. But I think that this does allow a little bit more lenient, especially since on the last papers we did pretty terrible, right? We definitely got fried by in 2018 and 2011. 2010 and 2017 didn't go too well either, I'd say. There were just a lot of stupid mistakes that we made that we shouldn't have made, to be honest. We shouldn't have made them. So reflect upon it, but more like just take a break, because I feel like doing 4 papers at once is definitely impossible, but 2 papers at once, while it's kind of like the actual TMUA, I would say we definitely need to build some more endurance before we get to that point. So, yeah, that's kind of a tactic here, and it's also going to allow me to keep talking because I think talking is quite important. Um, We'll see. I might increase this to 45, depending on how well we do on this paper. So let's say if we do better than 7 out of 10, right? So higher than 7, if X higher than 7, then we keep it as is. Otherwise, we keep it as 45. We increase it to 45 minutes per test because these are the MET papers. I would say these are the simplest of the things we're gonna do. Actual TMUA papers, I would say, are definitely harder. And also, we have no, that's not it. We have step modules. We have the foundation modules. There are 25 of them. Each of these are, oh Lord, how long are each of these? So yeah, so each of these are 3 pages or like 4 pages ish. So it doesn't say how long each one should take, but definitely this is interesting, and I think it will be a good thing to do. Oh, but there were differential equations. That's on step. That's on TMUA. Okay, whatever. We'll ignore the things on the TMUA for the step foundation papers. So, anyways, let's get to it. Let's open up the good old clock. Clock. Yes, I love clock. Right. Okay. So 45 minutes, which is too much. We're gonna change this actually. Yes. We'll see. I think we can do pretty well on these papers. We're gonna start chronologically because let's why not? We can see the evolution of the papers. So without further ado, that's what I always say, but just set up really quickly. Cool up all the necessary gadgets. Yep. And okay. You hear that because I have a HP laptop, so this is a 360. So I gotta flip it over so that I can draw on it every time. Okay, so without further ado, we've got a figure pen, so we should be doing figure working, so that will get us more marks. Here we go. Okay, so question 1, tangent of a circle. Let's see. So we can draw this very easily. Ta-da. So let's see. First one is this, and that's starting here. Ooh. Oh no, looks something like this, right? Yeah, no, that wouldn't work. How do you find a tangent again? Okay. So it's definitely not C, and I don't think it's A either. So it's either B or D, and B is looking kind of odd. So B is something like B is something like this, and Y is something like it starts at 2, square root of 2. Okay, so let's this has a radius of 2. So the D has the y-intercept like here, which doesn't make sense. So therefore, the only solution is B. Right, easy. Let B, which is a lovely question, with powers of 2. So we can simplify this into essentially this, right? Because we can just decompose them into powers of 2 and then add them together. And so it will definitely be a square number when what's a square number again? The square number is when it's odd, right? Yeah. So so A's wrong, B's wrong, K is odd, but that's wrong, so it's D. Duh. Right. That just gotta verify really quickly. Okay, so which is the smallest of the following prime numbers? Let's see. So we have 3 square root of 3, a log, so 4. So it's not B. Scratch that out. Wait. No, 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 no. It could be B. No, it's not this. Right. Free sine 60 is oh Lord, this squared, which is just this. Yeah. And then log 2, log 2. So that is definitely going to be larger than. Wait, sine 60 isn't. Sine 60 isn't this. Sine 60 again. Sine 60 is this. So actually, we're looking at something. Oh, fuck. So we're looking at something like this. So it's not that. It's actually this. 333, 17, which is not this. Okay, so this is then like slightly less than 4. So like let's say 3.9 something. Okay, so the smallest answer therefore has to be D, which happens to be the one I'm least confident about, which ain't great. But yeah, something like this seems to work. So we're gonna say it's D. Okay, so next up, D. Shown below is a diagram of the square with vertices and the line y equals x plus c, where the shaded region is the region of the square which lies below the line. The shaded region has area. Which of the following shows this as C varies? So obviously it's not D, because only when the y-intercept is -1 is it 0. Sure as sin ain't sure as sin ain't B either, because the increase isn't linear. So it's either A or C. And the increase when you're kind of going from here to here is the biggest. So the rate of increase at the middle is the highest, so it's A. Okay, next question. E. Which of the following equations could possibly have the graph given below? Okay, so it touches at points. It touches as a repeated root at a negative point, a repeated root at a positive point. Then it has a point there. So let's examine this, right? So it's probably gonna look something like this for option D. Is that just the correct answer? Looks a lot like the correct answer. Okay, so it's not B. It could be C or it could be D. Let's look at A. A is not A because it has repeated roots here, here, and then so like it would be something like this, right? And that's wrong. Or at least that's how I'm thinking about it. So it's either C or D, and we can tell the difference between the two probably by figuring out. Oh wait, it's negative. Right, the x is negative in this one, and so when x is negative, it looks something like this, right? Is that right? Yeah, yeah, yeah. When x is negative, then it goes the other way around. So it's obviously C. Okay, because the two are the same, other than magnitude and that sign. So f let t equal a bunch of integrals. Which of the following is correct? Oh, so we're just looking at the sign of these. Okay. So the first one is cos, which, as we all know, looks like this. And then we are looking at 90 degrees and negative 90 degrees. Is that right? Okay, so it's a positive. Next up, we're looking at sine. So sine is, again, like this. And we are looking at 2 sine, 2 pi, 2 pi, 2 pi, 2 pi to pi. Okay, right, and that's negative. And finally, this one is probably going to be a hard one. Yep, it's some weird bullshit. Is the Okay, the fact that it's dividing doesn't matter at all, right? However, the fact that it is being multiplied. Okay, so if you're multiplying it, then you're actually if you're multiplying it inside the function, then you're actually making it less stretched. So actually, it looks something like this, right? You're compressing it. Oh shit, I drew this wrong. Right. So you're actually looking something like this, and this would normally be 2 pi, but instead it's this, right? And now, how can we relate these two together? Wow, simple. It is this, right? So free, so it's in this positive area. Because this is 8. So this is 4. Yeah, so that's a positive area. So positive, so it's a positive area. So therefore, actually, it is A. No, it's not A. It's smaller than 0. So it's B. Oh, fuck. Almost were wrong there. Right. We have got surprisingly few questions left. These are going to be terrible then. Right. So the positive number x and y, we solve the equations. Solve the equations. I reversed y, and so I reversed something that goes like this. Okay, something that goes like this, and was essentially the same thing. Let's see, it's 4k minus 2xk. They have to intersect in this quadrant because they're positive real numbers. Hmm. Okay, so let's see. So this and this are quite not similar. We can look at this analytically, right? So if we just draw this, and then can we multiply everything by k? Yes, we can. So then it becomes, oddly enough, something like this. So now we need to find when does that solutions. Okay, let's see. When k is 0, then this become, you throw this over here, then this becomes this x equals 4, right? Then y is naturally equals to negative 4, which is not good. So k has to be a big number. So it's not A, it's not D. Let's test C. So these two cancel out. The x gets thrown over there. X equals 0. And as x equals 0, that's also false because that's not a positive number. Therefore, the only value is B. Huh? I guess. It's a bit odd. I will come back to this. A star. Right. Okay, so H. Oh, yes, lovely integrals. Okay, so in the region where, oh Lord, In the region where it go like that, it has solutions. Shitting. Shit. Okay, so sign, as you do, and then you gotta plug in the values. That's essentially it. You plug in the values, okay? So sign, right? I'm gonna try and make this easier on myself. So, if you plug in, say, one, that's somewhere like here, right? So it probably looks like this. And if you plug in negative one, like here, then it goes about here, right? So it also looks like this. So it can't be zero. That's a defined fact. They've told us it can't be zero. So zero is not a solution. However, 2 pi is a solution because this and this are going to equal each other. Yeah. Okay, so these two are going to equal each other when it's 2 pi, when x is 2 pi, so it's probably going to be b. Yay! Okay, let's look at I. The vertices of an interlocular triangle. Oh fuck, triangles. I hate triangles. Right. So we are drawing an equilateral triangle in a circle with circumference 10. Let P and A be the numerical values. Let me just have a drink real quick. Let P and A be the numerical values of the triangle's perimeter and area, respectively. Which of the following is true? So the fact that there is an equilateral triangle is the only relevant part. Oh no, we're looking at the triangles bits. Okay, so we can generalize this and put this at zero. The origin, the center at zero. The circumference is 10. So this, so pi is r, you know. And then we can look at the perimeter and area. So 1, 2, 3. And this is again a general case, which works for all of them. Hmm. Now the area is sine 60 divided by 5 equals area, right? And the perimeter is 3r. It should be quite possible in order to find what this is. So this and this are equals to r. Yeah. So let's see. These two are equals to r, right? So r and r. So therefore, how can we find one of these numbers? If we find the angle, we're set. Or if we find this, we're also set. Now we can split this guy up into three, so this is 60. Yeah, so this is 60 degrees, and since that's 60 degrees, then actually you can find out using cosine rule. Okay, so cosine 60, r squared, r plus r minus this mess, right? The 2. Yeah, I'm pretty sure there's a 2 in there. Equals funny length squared, right? So now this is just a half. So now it's r squared equals this. So r is equals to r. So yeah, what's it the value again? This. Okay. It probably didn't require this much working to figure out, but we figured it out anyway. So what can you do about it? Okay. What the fuck? I already knew what the values. I'm a dumbass, right? I already knew all the values. Never mind. I'm a dummy. Okay, so um well, okay, so that was just a massive ball of pointlessness. Right. So these are the values. Okay, so I guess we can put it like this, which equals to A divided by P, which so this is 5, this is 3, this is just pi, this is 1. So it becomes 5 pi. No, so that's not the answer. P squared is not rational. P smaller than A. Ooh, now that we could conceivably prove. No, no, we can't really prove it, can we? Okay, I knew this was gonna be tough. Okay. Oh Lord, what the hell is J? Ah, yeah, yeah. Tiana. Okay. Okay, so let's ignore a J for a while, because we have some time. Okay, so R, are we sure R is that value? The circumference is 10. Yeah, we're sure R is that. So sine 60 is equals to A. 3. I'm missing 3. This value is off by 3 because I calculated that. It should be times 3. So all of this is irrelevant. Okay, right, got it. Thanks, Mom. Fuck. Okay, so so these are the new values. So God, uh, can we just equal these to each other? No, this is this conclusive? So that's gonna be like 12-ish and that okay, fine, no. Never mind. So let's see. What about dividing one by the other? Right, that's always good. So AP, this goes out, this goes out, so it's square root or 4, which I don't like. Can we get rid of the square root? I don't like the square root. Square root is a pain in my ass. Because it's not a square root. What the fuck am I doing? It's 120! Because it's one fucking point! Oh my days! Okay, so, that was completely wrong. So, oh my god, okay. So, actually, this value is this. This, right? 1044R. Okay, well, that's still wrong. Right, we've done this like 3 times already. So, this is, right? Cross it out, cross it out, cross it out, cross it out. R divided by 4. R being, right, which is A. So A is correct. Okay, finally, now we move on to J. If two chords QP and RP on a circle. Having a drink. About beverages. Draw a circle. Radius 1. Meet at an angle. QP. Heck, heck, heck. Two chords. But you've not defined the chord any further than that. So really, it's like, what if you draw two tiny chords? Like, okay, okay. What if you draw like two tiny chords like this, right? The angle is massive, and then the entire thing is discovered. Yeah, okay, so what's the area of this? The area is just pi. Yeah, so the area is just pi if for the entire thing. Coincidentally, 180 degrees is pi. So actually, we need what is the area of a sector. Okay, so I think it is something like this to cover this, right? Okay, we've got 10 minutes left. We can work this out. So, so J, no, what? No, if PQ, hmm. Oh, wait, okay, I have a solution now. Right, okay, so let's remove all of that. Remove all of this, in fact. Okay, and approach this with calm mind. So we draw a nice circle. This is the center. We draw two nice chords. We draw this. Aha, linking it. And then this is pi. So let's assume that these two are equidistant. So like these two are the same size, not equidistant, but whatever. Since it's a chord, this bit is also equidistant. So this is actually 180 degrees minus pi. No, theta. So then we can work out pi minus all of that mess, right? So actually it's times 2, because there's two of them, r squared, where r is 1, that cancels out, minus, okay, minus 180 degrees, minus pi, minus sine, 180 degrees, minus pi. Now this is also pi. Yes, exactly. So these two pi's cancel out. So then it becomes positive plus sine over this. Beautiful. And since this also sine 180 degrees minus anything just becomes sine theta plus sine. And first the answer is B. Oh, beautiful, beautiful. Oh my days, it's beautiful. Okay, right, that was amazing. Work of art. I'm gonna be so pissed if that's wrong. Right. So let's go back to the beginning and check our answers because we're responsible individuals. We can clearly, without a hint of, okay, no, I gotta put this off. All right. So, let's see. So, if for A, let's draw a new one. So for A, the y-intercept is actually gonna be here, but it crosses straight through. For B, which is the answer of selected, we're gonna ignore that. For C, it's just a line straight through. For D, it's another like weird interception thing. So therefore, the only possibly valid solution is B. Let's move on to B. We have decomposed M quite smartly. It's a square number, which I assume means this, right? Or the other way around. But point is, it's D because they have to both be even. So these two have to add together to be even, and the M is always even, so it doesn't matter. So the answer is D. Was the smallest of the following numbers. So that's a great point. So sine 60 is this times this square rooted is 417, which is a huge number and therefore not it, right? That's also not it. 4 versus D. D is in fact correct. Yeah. So A, where the gradient increases the most as C is around 0. So in fact it is again correct. Beautiful. Beautiful. Amazing. No longer beautiful. What the fuck? Wait, I just realized this has a power of 5. So actually, well, if x is positive, then it should be like this. So x has to be negative. It's D. Whew. Good job, I spotted that. Yeah, has to be negative. Sounds about right. Which is again, indubitably, very positive. Yes, this makes furious sense. Oh, G is the one I didn't like. So all we need to do is look at G and H. So let's see. Right, so these are the values. What we sum in, k is equals to 0. Why was this? Is this a k? This is the k. Actually, yeah, you've got to multiply the entire thing, or else you end up multiplying by k, dividing by 0. This feels wrong. What the hell? Yeah, because it is wrong. Okay. Right, 1 minute left. We got this. So only k larger than negative 2. Let's test 0, right? 0 is. Okay, so it's not 0. What about 2? Shit. Okay. Right, so then these two cancel out. Mhm. Oh, because then these two are the same. So it's not all values of k. It's not d. Now, is that valid though? Right, so that's actually looking like this. So if both of these are looking like this, they're definitely positive values. Therefore, the answer is C. It can't be B. Finally, with the last 2 seconds we've got left, let's take a look at this. I don't know, man. It looks kind of right. So I'm gonna pause it right there. Oh, that was a nail biter. Alright, literally a nail biter. I bit my nails. So, okay, that went better than expected. Given answer is B. Given answer is D. Hmm. Wait, what? Oh, they're both D. Yeah, they're both D. Oh, thank God. Okay. Given answer is A. Oh. Given answer is D. Given answer is B. It's C. Oh, my days. What a fucking clutch. Okay, let's look at J then. Skip to J. It's me. Oh my days. The perfect working. It's A. Wait, did we actually just get a full run? Did we just get a full run? Come on. Come on, H. Come on, H. It's blue. It's so big. It's Oh my days. The perfect run. The perfect run. I couldn't have done that with a second less. Ignore the timer. That timer isn't real. Oh my days. Oh, beautiful. It's beautiful. We actually got every question right on the MAT multiple choice. Oh, oh my days. I mean, it was kind of an easy paper. But still, like actually, the bowling, right? It's like you're bowling and there's 10 pins and you hit all of them. I forgot what the term for that is, but the point is we bowled it. We bowled a perfect run, you know? Perfect run. This is a Royal Road reference. You don't know this, but it's a Royal Road reference. The perfect run. Okay, wow. God damn. Okay, okay. We got it. So now we have 13 minutes to just kind of chill because we don't need to check any answers. 'Cause we got them all right. We got them all right. Right. This should not have made me as happy. No, come on. It's deserved. Come on. Come on. That's pretty good. Come on. You know, we got them all right. Oh yeah, baby. Oh yeah. Right. Actually, yeah. Now I'm motivated. Damn. I'm gonna skip 2019, okay? Because that's the hardest paper. It's latest down the line. So we're skipping this straight to 2019. Yeah. Okay, so I'm gonna take a drink. Oh, oh, goddamn! Life never felt so good. Right. So, that's pretty good. I'm gonna go on break. How do I go on break again? Break. Mm, do I have to mute manually? Yes, I do. Okay, hello everyone, I'm back. Okay, so after a brief walk to enjoy the exuberance of life, we still have 8 minutes left before we have to begin our next paper, so I'm just gonna do a bit of talking. So, hello everyone. This is the first time that I've not been doing an MAT paper and talking just to myself. Got some cool vibes going on here. So I'll tell y'all about some of the plans we got coming up. So right here I got a notebook that I acquired from the good people at Trinity College, Cambridge, and it's a very nice notebook. Well, not really, but it's a better gift than like any other that we've gotten. Like, Imperial also gave me a notebook, but it's falling apart, and I haven't even touched it once. So yeah, I'm judging Imperial based off the quality of their notebooks. Like people talk about accommodation, like the quality of education, but the real thing you should be judging any university by is the quality of the stuff they give to you for free. Trinity, definitely very top tier because they gave me this huge notebook, right? This notebook, let me measure it in order to give you a sense of how brilliant it is. So, this notebook is 20 centimeters by 13 centimeters. That's a huge notebook, okay? And that's because Trinity is the wealthiest college in the entirety of England. They beat all of the good people, even at like Oxford. Oh yeah, Cambridge Trinity College. In case I didn't mention that. So it's very nice. It's a very nice gift. Not a gift, just something they hand out. But I can, in fact, read from it and see what we've got going for the week after. So on Monday we've got reviewing some wrong questions from 20, which all of the papers we did today and yesterday and etc. So I already scheduled the stream just before, so it's going to be very fun. It's going to be me picking out a bunch of the questions that we got wrong, and we're gonna do them live on stream, but we're gonna go at a bit of a chiller pace because the past couple of days we've all been going rah rah rah. We've gotta finish the paper in the end amount of time. But really, what's important is also training our interview skills. So we are gonna be, kind of going through the questions, asking the appropriate verbal questions about the questions, questioning ourselves, questioning reality, questioning the professor. The non-existent professor, anyways, the imaginary one. So that's that. So that's gonna be fun. On Tuesday, we're gonna start doing. We're gonna try something out that I've not really tried out before, so it's gonna be the first time we do downstream. It's gonna be the TMUA .co.uk website, which I haven't really gotten it recommended from anyone. There is another website which I did have recommended, but that one's not gonna be up until June-ish. But the point of this is that it generates AI questions for you. So we're going to do the diagnostic that it has by default. I'm going to kind of register an account as you do, and then we're just gonna have some fun. Yeah. So that's gonna be that. On Wednesday, it's gonna be fun, very fun. We're gonna learn about NIM. So NIM is a kind of game in game theory, not game, of course, in game theory, where it is mathematically impossible to win it once you get into a winning state, and you can manipulate yourself into being in the winning state if you are the first to move. So there is kind of a set pattern of like a set algorithm that you can use to determine how to play NIM optimally, and I think that's pretty cool. So definitely that's what we're gonna do is we are going to try to program NIM, and while NIM itself, the algorithm isn't too complex, I'm going to be doing it in C++, probably. I haven't really decided yet, but the reason we want to do it in C++ is because the languages that I would say I'm most familiar with are Python, Java, Kotlin, etc., etc. None of these are really built for kind of more algorithmic programming. Like competitive programming, I did used to participate in the BIO. It was so bad. I was so bad at the BIO. But, you know, I used Python, which did have for you some no, not algorithms, some libraries available to you, like Functools. Functools enabled you to basically do Elite's recently used cache without having to implement a hash map or a dictionary or anything. Basically, all you have to do is put up a function annotation, which is quite neat. It's quite a nice way of speeding things up. But yeah, definitely we've got to move past Python. So I'm going to try and also learn C++ at the same time. So it's gonna be a long stream. It's gonna be a tough stream, and we're gonna see how far we get. I don't expect to finish them, but hopefully we will be able to finish it because once we do, I have an idea for a short, the second YouTube short that we're gonna do. And then on Thursday, we're just gonna do more MAT papers. So we're gonna do probably 2020 and 2011. Yeah. So that's just gonna be that. And then we're gonna do some filming and editing on Friday, but that's gonna be off stream. So hopefully I'll post something on Friday. Then on Saturday and Sunday, it's gonna be a lot of things, a lot of things. I might go for the SAT again, so I might do a second try of the SAT. I don't know if I can do it live on stream though, because I've got a College Board account, but it is registered with my real name, which I can't leak yet. Then there's also a bunch of fun stuff like linear algebra and stuff but that might be more suited to off stream. I want to see if I can post a stream highlight, either tomorrow or next week weekend, and I also want to see if I can set up a VTuber model because VTubing is kind of a, it's not really an interest of mine. Like, strangely enough, I don't watch VTubers. I don't watch streamers at all. So that might be really weird to hear from someone who is actively streaming. But I don't like watching streamers because there's just not there's not enough stimulation all at once, right? That's what I think about streaming compared to things like YouTube, like long form or YouTube Shorts, especially, like you just get hit after hit of dopamine. You get the best moments cut out from every stream, and kind of compared to that, streaming is a lot more low key. So I feel like streaming is kind of a gateway drug in that sense. Like you get hooked on streaming, and then you go, "Oh, I want more of these funny moments," and you go on long form for like compilation clips, and then clip compilations, the other way around. And then you go on shorts eventually because it's just like go pump after pump after pump of dopamine. But yeah, so I don't really love VTuber culture as a direct result. I did try to get into it multiple times. I just couldn't find anyone I particularly liked. And definitely now is especially when I will not be getting into VTubing. I've got my own YouTube things I want to do. I've got, all of the stuff I've got to prepare for Cambridge and all that. So unfortunately, there is gonna be no getting into VTuber culture for me. But I want a VTuber model because there's kind of a psychological effect of having someone, right? Having someone who you can see on the screen there because humans are naturally attracted to other humans. We are a social animal. I think that's what you call it. We are we are social animals. Social animals. And thus, if you put a big nice picture of yourself on the thumbnail, it's gonna get more views. And a VTuber isn't a big fat version of yourself, and especially since it's gonna be a default one that I download somewhere off the internet, it's probably not gonna improve the click-through rate or anything by that much, but it's something nice to note. It's something nice to see rather than just, like an empty screen like what you got now. Yeah. So anyways, that should be an hour. Yep, I got it on the dot. So I'm gonna have a drink of water again. So, okay, so now let's go and do 2019 as promised. Okay, so we're resetting this. Let's decrease it by a minute because I feel like that's funny. So it will be 39 minutes for this one, and then 38 for the next one, and then 37. Okay, so this patch will be detached and not marked. Congratulations. So 2019, time allowed 2.5 hours. Please complete the following details. Upwards applicable. Here we go. So, the equation. So, this is the equation. It has how many solutions? Interesting. So we can look at the derivative. So we can derive this as being the turning point, and then it's gonna look like this. So it's gonna be -1 or positive. It's gonna be -10 or +10. So then we can draw something like this, and then we can sub in y into each of these. So we can therefore conclude this my plus 3000 minus 3000. So y is going to be negative here. And then for positive, it's going to look even worse. Yeah. So it's also going to be negative. So for both of these, it's negative actually, which is quite curious. So the turning points are at here and here, and they're both negative, and it's coming from down up, so it's going to look something. Yeah, it's going to look something like this. So it's going to have exactly one real solution. So that took way too long. Uh, it took me 2 minutes. So the product of a square number and a cube number is always a square number and never a cube. Ooh, this is interesting. So what you're saying is, x squared times y cubed, right, equals what? I mean, we can think of it pretty easily, right? Like we can do some numbers. So already this 36 is a square number. So b, it's not d. Always a cube. What's a cube again? This isn't a cube, right? It's not cube. No, it's obvious. Right. So next up, it's just A and C. So we need to find an example where it is a cube number. Yeah. So let's see if we can find a cube number. Wait, what the hell is this? 3 cubed. It's 8. So actually, this is 32. Okay, forget what I just did. I just did that wrong. Okay, so 32 is not a cube number, I hope. Yeah. And it's also not a square number. Again, I hope. Is it? Yeah. Okay, yep. So it is. So anything that's always is wrong already. So B is wrong, that's wrong, E is wrong. So it's either C. Okay, wait, but fundamental theorem of arithmetic. So we can consider it like 2 to the power of 3 times 2 plus. Okay, I think if the this and this has different like prime factors, then it's never gonna equal like square root of q. I think that's a reasonable assumption to make. So what we are really looking at here is not this, but this. So actually, 2x plus 3y equals some number. Can this be divided by 2 or 3? Well, obviously, yes, because make x 1, right? So, yeah, you make x 1, You make y2, so it's 4 plus 64 cubed. 64 is a cube, right? Yeah, 64 is a cube. So 64 times equals 256, which is a square, and hence it is sometimes a square. Yeah, so we can just rule things out until we find the answer. So, okay, let's hurry. The graph of this is sketched in a way. So, when x is 0, it's obviously 0. So, a is right out. Now let's look at something that differentiates all of them. What about when it's 90 degrees? So, when it's 90 degrees, then it's always 1 plus 1 squared. Squared plus, and then 1, 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 and then so on, right? So, therefore, it's either D or it's E. What happens when it's negative? So it's this. So it's therefore 0. No, that's cosine. So it's looking somewhere in here, right? That's 90 degrees. That's 0. So it's D. Because at 180 degrees is just equal 0. So that D is the only one that fits. Right, so that's easy. D, the areas between the parabolas are this and this. What are the possible values of A? Interesting and terrible. Okay, so let's draw these out. So the second parabola is negative. So it's going to look like this. And the first parabola is something looking akin to this. Yeah. So it's going to look translated by negative A. So it's going to be somewhere over there. It's probably going to be something like this. Yeah. And the possible values of A are okay, shit, I've forgotten how to do a definite integral. Wait. If you're summing up all of this, right? Okay, so I gotta avoid the dead air. Okay, I'm serious. Okay, okay, okay. Something's hitting, right? I'm really tired all of a sudden. I don't really know why, but I just kind of am. I think this is some kind of like long-term consequence of me not talking a lot, staying at home too much, and now I can't really talk for extended periods at a time. So I'm gonna keep doing this for half an hour, but I don't think I'm gonna do too well. Okay, with that said, let's continue. Boop. So the areas between the parabolas with equations this and that are. So first, for Mr. Top, we've got to find out is something horrible like this. So you can take out the x, therefore this, right? So happily enough, one of the intersection points is always going to be 0. So it's going to be 0 or negative a. So those are the 2 points. So actually, now I'm going to try and redraw this. So x is 0 or negative a. Let's assume a is a positive number for now. This might come back to bite me in the ass, but whatever. Where y is then a or a minus a squared. Maybe we could differentiate this. Oh wait, that actually does give us useful information. So the turning point and the place where it intersects are the same. That's kind of surprisingly useful, actually. Negative. Thinking about it, it probably will. So okay, you know what? I have too much of a headache from this question. I'm gonna skip it and do some easier things like sine. Oh Lord, what the fuck? How many straight lines does it include? Straight lines? Straight lines? What in the fuck? Okay, wait. So this is then sine squared x Hey, so this doesn't help us at all, but now we've got some numbers. No, we don't. What the fuck? How do you acquire straight lines from this? I don't understand. The remainder of these questions don't even seem that hard. It's just like this one particular one which bowled me over. I was fine up until D. I don't know. Okay, wait, pause. What the fuck? I've actually been hit with like a mental wave of exhaustion for some reason. Like I'm about to fall asleep. I don't know why. Okay. So straight lines. I have no idea how to even begin graphing this, by the way. Just to make it perfectly clear. Yeah, I'm not doing four papers right now. I'm cooked. I'm fried. Let's sub in zero, right? Subbing in zero always does something. When it's zero, sub it in. Correct. This is just become zero. Y could be either zero or one. And the same applies for x. So, okay. So now your plot point here, your plot point here, and your plot point here. And if sine is, let's say, equal to some normal number like sine x, if x is this, right? Then it goes to zero again, and the numbers stay the same. What if it's like this, right? What if it's like that? And that doesn't make sense because we can't solve that. Low key, no idea. C. Also, no idea for this one. D. Is there D? Is D even a value? Yeah, D is a value. Okay, so in the interval, this the equation. Okay, this one we can solve. Come on, this is easy. So all this is right, right. Therefore, from this we can then contextualize. right? It's probably gonna be like this. 'Cause effectively, they've got to cancel each other out here. No, they don't cancel out there. There's a point here where they cancel out. Point here where they cancel out. No. It's probably a point here where they cancel out, though. So the answer is C. G. Let them all be above zero. The equations. Hence they said, what the fuck? With this paper, what the fuck? This ain't. What? We ain't seen this before. Huh? A, B, and C uniquely. What? What you're saying is, if they're all equal to 1, so it's not E. Great, we've narrowed it down, lads. So probably sub it in like this. Which might seem worse. And you realize, no, you can actually get rid of all three of them. So at least one of them is specified uniquely. Lord, oh Lord, what the fuck? Like, that has to be the only way in, right? I would take a very guess. A very guess indeed. I have no fucking clue what this question is on about. What? None of these guesses make sense, though, is the thing. I don't know. No clue. Oh, triangle, right angle, that'd be. Side numbers are positive. Geometric. A, B, C, where? A is A, B is AR, C is AR. Mm, C, this. Fuck. And is sine cos. They cancel out. That's the whole point. How is right angled? Doesn't help us. Or maybe it does. Maybe. That seems helpful. And it is no longer helpful. Or we could just plug it in. Or mm, or is this? Therefore, it is A. Or it could be D. I really don't know. Next up is I. Log it. No, no. I I don't know anymore. It's like graph edit. Would probably look like this. Probably look like that. This is an inversion. It meets at one point. Or no points. That's a fair one. Because they're infinitely close to each other, but they never reach each other. Because log x just keeps just trying to reach. Fine. 8 is J. And a fucking the triangle has a center and a side length. Revolutionary. Straight line. Below. Intersects triangle. At 2 points. Shortest possible length. See? I'm not working this out in a minute. This is doodling at this point. I don't. These are not useful insights that I'm putting into here. Thinking was a line that approaches from here might help, but I also have no clue. So, all right, well, I guessed some answers for all of them, so I guess that's my paper done. Right, so I'm gonna quit doing now because I don't think this is really gonna be all that useful to me. B, C, or D, B. Oh, come on. It's the one I'm fucking up. Right, C. C, that's something that I understood. G, A. Wait, C was one of the answers. What was C? You just miss it. I did just miss it. Oh, fudge. Right. So C was the answer. Oops, I should have gotten that. And which I somehow guessed right. So one, two, three. Okay, well, 7 out of 10 isn't that bad, but when you consider my mental state while doing it and the fact that I guessed some of these, yeah. I don't know, something about E just broke me. The D, sorry. D just cracked me in half. Fuck. What's E? What the what's the answer E? Okay, so it's not good. Let's graph E, right? I spent a couple minutes, I spent like a while just now uh, imagining E, the question of E popping up in my nightmares. So I guess I'm typing this in by hand. I next. What in the fuck? What in the fuck? But Tomato. Why? Rose, why? How was I supposed to work that out? How are you supposed to work that out? I don't get it. How long the stream been going? We've been going for 2 hours. It feels like a century. How in the hell? How in the hell? What? How in the hell are we supposed to work this out? No. Wait, this is why. X. Oh, wait. What the heck? What's this question? What kind of magic trick is this? I don't understand though. How in the hell? Oh, wait, suddenly I see the solution. We're just supposed to plug in this. Let's try this, right? Yeah. So, okay, I feel like my mental abilities are returning to me all of a sudden. Okay, this is zero. I'm on a zero. Minus the cos, the big cos is one, minus this. So zero, zero. And so from there, you could have probably extrapolated that this works as a straight line. Then how would you have figured out that? Right? Because you would have probably had to plug in something like, oh lord, you would have probably had to plug in like, you need two lines. So you need x equals zero. Oh, fuck off. Bugs around the place. Right. You would have probably had to figure out x. No, not x. What? Okay, let's just write down the points first. Okay, so one of these is x equals 0, 2 pi. The other one is 2 pi, 4 pi. Let's plug these in. Let's plug these in. Sin x 0, 2 pi 0 equals cos x 1, 2 pi 1. Right? Yep. So you could have probably done the same thing here and figured out 0, 0. And from there, you could extrapolate to 1, 2, 3, 4 infinite lines. Okay, so that is just like a mental trick that you had to know. So you just had to plug in numbers smartly. I'm gonna ignore D for now. Never mind, I can't really ignore D because that's the only one I got wrong that I don't understand yet. Okay, let's not look at the solution yet. I mean, I know that you guys looked at it. You can probably go back and pause on it, but I didn't look at it with like open eyes or like an open brain. So, okay, let me eat this cookie quick. Mhm. Okay, so what we're actually gonna be calculating with our integrals here is the area between here and here for the up one. So for the second integral, no, for the second parabola. So for the first parabola, what we are actually gonna be getting is this. Yeah. So what we need is, okay, let's number these 3, 2, and 1. So what we need is 1. Okay, so that's the positive area here of the second parabola plus the bomb bits. And the bomb bits is negative 3, because remember the value of this definite integral is going to be negative because it's below the x-axis. Weirdly enough, it's going to be plus 2. So the 2 is this bit of the second integral, as the second parabola. And now we can draw up nice little integrals to define each of these. Like, first one, the bounds are from here to here. So where does y equals 0? That's simply square root of a, plus or minus. That one, it's going to be minus square root of a, 0, or this. Next up is negative 1, which is going to be, and I also forgot this, right? There's this horrible bit. Oh, wait, actually, no, it should be the other direction. So there's also that bit which we missed. Right, yeah. So this way is for the positive for the first one, and then this way is for the second one. Man, not having a timer is making this much more relaxed. So actually, we missed out a fourth one, which we've got to put in now. And actually, I'd like to kind of move this entire thing away so that we have some more space to work with. So how about we do bit it is. Right. Move this there. It was it's time to move it a bit farther. Right. So now we're just in the plains. No one to disturb us. I'm also gonna pull out my pencil bar again because I would like a pencil bar to work with. Okay. So, so. Back to Mortal Kombat with this beast. Number three. What is number three? Number three is the intersection here. Which, as we all know, simply x 0. So what we need is a quadratic formula. Minus 4a. Put 2 out. So this becomes this. Wait, no, this becomes squared. Okay. I cannot help but feel like this is too complicated. Right. I really okay. Let's just get a vibe for the solution because this feels way too complicated, man. Like, ah, okay, that's an interesting trick they've done, which completely invalidates all of my work. But we'll worry about that later. So what they've done is if they've also drawn this, they've also drawn. No, they haven't drawn shit at all. That's my conclusion. They haven't drawn shit. They know zero is one of the points where they collide. They know negative a is one of the points where they collide. Okay, I'm pulling out the harder textbook because I forgot about this. Right. How do you find the area of like something as complicated as that again? Okay. So the technique that we forgot is essentially this, right? So in order to find the area between f of x and g of x, all you have to do, between or between these two, obviously, bounds, and right. So here's an integral f of x dx minus f of x g of x dx. This is actually the only thing that you need. You can simplify this even further. We're doing f of x g of x dA. And so this will basically account for all of these tiny differences here. So you don't have to worry about the signs for all of these adding together and making the answer wrong. You can just do this. That is kind of funny. I spent this long trying to figure this out. So the answer is that simple. And so, yeah, kind of makes me feel like a dummy. So really, it's just this. But I feel like I was missing something here. They also put a modulus sign. So they did. And damn, you can't blame them. They did do that. They put a modulus sign. I guess. So that's another technique, I guess, which is if in doubt of signs, put a modulus sign. If in doubt of more signs, put another modulus sign. And then eventually it will modulus out until it moduluses and you'll get the correct answer. One hell of a lesson to take away from this, lads, is modulus until it goes away. So actually, wait, since the first one is bigger than the second one, but you're modulusing the entire thing, so yeah, you can just put them in any order you want. Okay, let's go back to this, right? So what they're doing, they are having all this, and then you're doing this, and then you're doing this, and then you find out the possible values of a, and you're also modulusing it, like the entire thing. So a's cancel out. This becomes 2a squared. Modulus. Modulus. I love modulus. So you modulus the entire thing like that. Then you just do a bit of, normal integration. Normal integration. You get this. And then you modulus it. Then you modulus it again. And you realize you messed it up. You already integrated the entire thing. Modulus. And that's minus. Because while 0, this entire thing confuses nothing, then this is actually minus 0. Fortunately, we've got another modulus, which makes it all modulus away. Final answer is this. G equals 9. Which seems wrong already. Ooh, man. Guess that's the answer. Yay! It's been 2 hours. I don't know really what to say. The first one was brilliant. The second one was the Godforsaken Mess. So, yep. Okay. See you tomorrow. Boop.